Hello everyone. So in this lecture we are going to discuss chapter-wise PYQ of NEET examination. Okay. So without delay, let's start. So here question number 1 is, if force F, velocity V and time T are taken as fundamental units. Mind here, fundamentals unit. Clear? Then the dimension of mass means you have to tell the dimension of mass. So mass dimension is equal to force dimension, velocity and time. Power A, B, C. We have to only find out power A, B and C. So without delay, let's see. Mass M having dimension capital M will be equal to force dimension M L T minus 2 power A, velocity L T minus 1 power B and time T power C. I am assuming here that you are well aware of the dimension of most part of the quantity. Means, for example, you are well aware about force dimension, velocity dimension and dimension of time, etc. So let's see here, m to the power 1, l to the power 0, t to the power 0 will be equal to power a, l to the power a, time to the power minus k twice of a, and l to the power v, t to the power minus b, and time is c, time to the power c. So all are in multiplication, so power must be added. M to the power a, l to the power a plus b, time to the power minus k twice a minus b plus c. Okay, and on this side m to the power 1, l to the power 0, t to the power 0. So compare right here, m to the power a equal to 1 and 0 equal to a plus b, means b is also equal to minus to the 1. A is 1, b is minus 1, and 0 equal to minus 2a minus b plus c. Substitute 0 will, c will be equal to 2a plus b. 2a is twice into 1 minus 1, that will be equal to 1. It means a have power value 1, b is minus 1, c is 1. So put it right here, means m is equal to f to the power a means 1, b is minus 1, sorry, b is velocity to the power b, that is minus 1, and time to the power c, that is 1. It means f is having 1 power, velocity is power minus 1 and time is power t. So option D is correct. Now next to the next question. In this experiment, 4 quantities A, B, C, D are measured with percentage error. It means you have given percentage error A, B, C and D respectively. Then P is calculated as, means P equal to A to the power 3, A to the power 3, B to the power 2 upon C, D. Means if we are going to count down percentage, then 100 will be equal to power is dropped ahead, and then a relative error of A into 100 plus B to the power 2, means 2 into relative error of B upon B into 100 plus relative error of C upon C into 100 plus relative error of D upon D into 100. And now just put the value A, B, C, D having power 1, 2, 3 and 4% respectively, means 3 into 1, 1% plus 2 into 2% plus 1 into 3% plus 1 into 4%. It means 3 plus 4 plus 3 plus 4. 3, 4, 7, 3, 10, 10 and 4, that is 14%. 14% is correct. Now next question. The damping force of an oscillator is directly proportional to the velocity, means force is directly proportional to the velocity. The unit of constant of proportionality R, means F is equal to K times B, where K is proportionality constant. Proportionality constant. You are well aware that if we remove the proportionality, then on that place a constant appears. So F is K B, and we are going to find the unit of K, means K will be equal to force upon velocity. So force is kilogram meter per second square upon velocity meter per second. So let's say K will be equal to unit of K, not K, actually it is unit of K, will be equal to meter to meter cancel, kilogram upon second square, and this second goes right up here. Second to second cancel. This means kilogram per second or kilogram second inverse. This is right. So next question. Dimension of dimension of mu naught epsilon naught to the power minus 1 by 2. So question is simple. Mu naught epsilon naught to the power minus 1 by 2. Clear? Minus 1 by 2. It means dimension of, let me sort out this, 1 upon under root mu naught times epsilon naught. And you have to be remember that this quantity is actually speed of light. It means dimension of speed of light, symbol c, means you have to tell the dimension of speed of light, means dimension of speed, or say velocity, that is dimension lt minus 1. So let's see, lt minus 1, this option is correct. Now the next question is dimension of 1 by 2 epsilon naught a square. So you have to remember dimension of 1 by 2 epsilon naught a square. So there are two ways to approach this question. First, you have to remember that this quantity is actually nothing but energy density. So energy density is actually dimension of energy density, E density. So energy density is nothing but dimension of energy divide volume. That is actually energy density. We are remember that density is nothing but mass upon volume. So in our case, the density is energy density. So energy upon volume. So let's see dimension of energy. So energy is nothing but work done. Work done means force into displacement upon volume. Volume dimension is L cube. Force dimension is mlt minus 2, and distance L upon L to the power 3. So on top ml square t की power minus 2 upon L to the power 3. So let's see m L to the power minus 1 t to the power minus 2. So in our case ml to the power minus 1 t to the power minus 2. Okay, so second option is correct. Now next question. The dimension of physical quantity are given by m to the power a, L to the power b, t to the power c. Then the physical quantity will be, means m to the power a, L to the power b, t to the power c. So if a becomes 1 means m, b becomes 0 means L to the power 0, c becomes minus 1 means t to the power minus 1. Velocity, it will be velocity? No, because velocity dimension is L to the power minus 1. So this option is incorrect. Now next, m to the power a. So first of all, you have to concentrate that m to the power a means mass is right there. It means acceleration will not be, because L to the power minus 2 is acceleration's dimension. Next, force. So force dimension is mlt minus 2. But in our case, if a becomes 0 means m to the power 0. So it will not be satisfied. Then pressure, m L to the power minus 1 t to the power, sorry, m L to the power minus 1 t to the power minus 2. So it will be unit of pressure. Option D is correct. Now next question. If the error in measurement of radius of sphere is 2%, then the volume of the error in volume. So error in radius means delta r upon r into 100 will be 2%. So error in volume means you have to remember the volume of sphere. So volume of sphere will be equal to 4 by 3 pi r cube. This quantity is useless. So volume directly proportional to r to the power 3. It means delta v upon v into 100 means percentage error in volume will be equal to 3 times percentage error in radius. Okay, quite simple. 3 into 2, it means 6%. So in our case 6% is option 4. So next question is dimension of resistance in an electrical circuit in terms of dimension of mass, length, time and current. So dimension of resistance R. Dimension of resistance R. Resistance will be V upon I and V will be W upon Q into I. You have to remember this formula. Potential equal to work upon charge, unit charge. So R will be W ml square t minus 2 upon charge. Charge is current means I and into time, because I will be Q upon T and Q becomes I into t, right here. I into time. Time dimension is t, and then current again I. So if we solve this, then ml square t minus 2, and on below it will I to the power minus 2 and t to the power minus 1. So it becomes m l square t to the power minus 3 and I to the power minus 2. Ml square t to the power minus 3 and I to the power minus 2. Option number second is correct. Now move to the next question. The velocity of b of a particle at time t is given by. So formula of velocity is given. A, B, C are constant, then dimension of A, B, C and R. So velocity is AT plus B upon C plus T. C plus, sorry, C plus T. Now you are well aware this fact that on the left hand side dimension will be equal to the right hand side dimension. It means dimension of velocity will be equal to dimension of AT and dimension of B upon C plus T. And C is also the dimension of T. It means dimension of C will be equal to dimension of T, and T is time, so dimension of C becomes capital T. So, and on the left hand side, dimension of velocity will be equal to dimension of A into T. It means dimension of A becomes dimension of B upon T. It is quite simple. So B upon T means LT minus 1 upon T time. So it becomes LT minus 2. Dimension of A becomes LT minus 2. So in our case, two options are given in this, option D and option B. Dimension of A becomes LT minus 2, but we have found that dimension of C becomes delta. So dimension of C becomes T. It means option B is correct. No need to find the dimension of B, as we are going to approach from the options. Now next, ratio of dimension of Planck constant and that of moment of inertia is the dimension of. So let's see, ratio of Planck constant I upon H upon I. It means H is dimension of H and dimension of I. So we have to remember that E becomes H nu, means H becomes E upon nu, and E is frequency. E is frequency having the dimension T to the power minus 1. Okay, so H becomes E upon I into nu, and I is moment of inertia, that is m r square into nu. So now let's put dimension. Energy dimension is ml square t to the power minus 2, same as the work dimension. Mass m, radius r, that is l square, and dimension of nu is t to the power minus 1. Now just solve this. M cancel, L square cancel, t to the power minus 1 goes upside, and t to the power minus 1 only remains. It means dimension of h upon e becomes dimension of frequency, because it is t to the power minus 1. Now move to the next part. So right here, dimension of universal gravitational constant R. It is quite simple. You are well aware that F becomes Z mass m1 m2 upon between distance r square. Z becomes F r square upon m1 m2. So just put down the dimensions, m l t minus 2 for force and r l square upon mass square. So it becomes m to the power minus 1, l to the power 3 and t to the power minus 2. It is quite simple. L to the power 3 and t to the power minus 2. Okay, so right here, option 1. Now next question. Unit of permittivity of free space epsilon naught is. So you have to just count the unit. Force is from Coulomb's law 1 upon 4 pi epsilon naught q1 q2 upon r square. If we have to count the unit of this quantity, then place it right here. Epsilon naught becomes q1 q2 upon f r square. This quantity is just a number, so it has no unit or dimension. So unit becomes coulomb into coulomb upon force Newton into meter square. It means coulomb square per Newton meter square. So let's see, coulomb square per Newton meter square. Now next question. The dimension of Planck constant equal to that of dimension of Planck constant. Dimension of Planck constant is h is equals to a upon nu. and dimension of E ml square t to the power minus 2 upon t to the power minus 1. H becomes ml square t to the power minus 1. Now this is dimension of H ml square t to the power minus 1. So energy is not here. Momentum is mass into velocity, and mass is m, velocity is lt minus 1. So in our case, L square is also angular momentum is L is equals to I omega. So let's see, I omega is so I omega is m r square into omega. Omega is angular frequency, and angular frequency is same as frequency because omega is equals to 2 pi nu. Now let's solve it right here. L is equal to I omega, means L is equals to I into 2 pi nu. I is mr square, it means m L square and t to the power minus 1. So it becomes m L square t to the power minus 1. So Planck constant has dimension of angular momentum. So next question is, the dimension formula of magnetic flux is, means you have to count down the magnetic flux, that is phi b will be equal to b into a. Now b is magnetic field, a is area. We are well aware about the dimension of area, but we are not yet known the dimension of field. It means f, if you are known to this formula, I am assuming it, f equal to qb v. V will f upon qb, force upon charge into velocity, and I is q upon t. So q is it. So I am just finishing this formula, it into v, velocity. So without delay, put down these values in our formula, actual formula. So dimension of phi will be equal to dimension of b into a, and b is force upon current, time, and velocity into a. So let's see, force is mlt minus 2, area is l square upon current is a, time is t, and velocity is lt minus 1. So let's see our final answer, ml cube t minus 2, and from below it is a and a minus 1, and t to t cancel, this is cancelled by this, and l minus 1. So it becomes m l square t minus 2 a minus 1, ml square t minus 2 a minus 1, ml square t minus 2 a minus 1. Option C is correct. Now next question, the density of a cube is measured by its mass and length of side. If the maximum error in measurement, the mass and length are this and this, then the error in density would be, means in mass it is 3% and in length it is 2%. Let's see, density of anything is mass upon volume, and for cube volume is L to the power 3. So percentage error in density will be equal to percentage error in mass plus 3 into percentage error in length. So put down the value. For mass it is 3%, and for length it is 3 into 2%, that is 6. 3 plus 6, that is 9%. So 9% is our correct answer. Let's see next question. Percentage error in measurement of mass and speed are error in estimating the kinetic energy. Mass is 2%, velocity is 3%. So I hope you are not new to this formula. Kinetic energy will be equal to half mv square. So delta k upon k into 100 means percentage error in kinetic energy equals to percentage error in mass into plus 2 into percentage error in velocity. These two right drop at ahead of that quantity. So let's put, for mass it is 2 plus 2 into, for velocity it is 3. 2 plus 6, that is 8%. So 8% is correct answer. Now move to the next part. Which of the following has the dimension of pressure? Dimension of pressure. Actually pressure is force upon area. So without delay, put down the dimension, mlt minus 2 upon area L square, and see ml minus 1 t minus 2, ml minus 1 t minus 2. Option B is correct. Let's see next question. The frequency of vibration f of a mass m suspended from a spring of a spring constant k is given by relation this one. Means f is a m x k y, where a is dimensional and constant. This is constant, so just ignore it. And x and y are we have to find. So frequency is directly proportional to mass into x, spring constant y. Let's see. I think you know this energy of spring, that is potential energy of spring. Let's see, this is u. Potential energy of spring is half k x square. X is displacement. So k is k is k is 2u upon x square. So dimension of k is dimension of energy, that is ml square t minus 2, and dimension of length का length square k will be m t minus 2. So let's see, we have find out the dimension of m, k and m. Right, put down here f directly proportional to m to the power x, and k is mt minus 2, mt minus 2 to the power y. Let's see, f is frequency, that is t minus 1, will be equal to m to the power x and into m to the power y t to the power minus 2y, right here. Let's see. So compare t to the power minus 2y equal to minus 1, y will be 1 by 2. And next 0 will be equal to x plus y. It means x is minus 1 by 2. X is 1 by 2 minus. X will be minus 1 by 2 and y will be 1 by 2. Minus 1 by 2 and 1 by 2. Option D is correct. Now move to the next question. If x equal to 80 plus bt square, where x is distance in kilometer while t is time in second, unit of b is, x is 80 plus bt square. So unit of x will be equal to unit of bt square, and we have to find the unit of b. So unit of b will be equal to unit of x upon t square. Let's see, x is in kilometer and t is time second square, kilometer per second square. This is correct. Now move to the next part. The dimensional formula of torque is, so we all are known that tau is r cross f, or tau is rf. So dimension, length, and force mlt minus 2. So it will be ml square t minus 2, ml square t minus 2. Option A. So next question is, plane angle and solid angle have, 2022 question, plane angle. So plane angle is plane angle, or say theta, that is arc upon radius, and it has no dimension because arc is length and radius is length, so both are cancelled. So no dimension, but have unit, why? Because unit of angle is radian. Okay, now let's see for next, solid angle. And solid angle is area upon radius square. Okay, so it is also have no dimension, l square upon l square, no dimension, but have unit, and that is star radian. Okay, so option is this, units but no dimension. Okay, now next question, dimension of stress. Actually stress is force upon area. So force is m l t minus 2 upon area is l square, so it becomes m l minus 1 t minus 2. Okay, so option C is correct. Now next question, if the dimension of critical velocity vc of a liquid flowing through a tube expressed as this so then you have to find the value of x, y and z. Let's see, critical velocity vc is given as directly proportional to eta to the power x, rho to the power y, r to the power z, and we have to find the power of these variables. We know that f is 6 pi eta r velocity. Why? Because we have to find the dimension of this variable. We know this, but we are not aware about this. So let's see, eta becomes f upon 6 pi rv, and eta is force mlt minus 2 upon r l, and velocity v lt minus 1. So l to l cancel, and this one becomes ml minus 1 t minus 1. This is dimension of eta. Now let's see. Critical velocity is equals to eta to the power x, eta to the power x, rho to the power y, rho to the power y, and r to the power z. So critical velocity is also a velocity. That means lt minus 1 will be equal to ml minus 1 t minus 1 to the power x, rho lt minus, sorry, rho is mass upon volume, mass upon volume. So mass upon volume, volume means l to the power minus 3, and y and length z. So after combining these, m to the power x plus y, l to the power minus x minus 3y plus z, and t to the power minus x. After comparing this, lt minus 1, m to the power 0, l to the power 1, t to the power minus 1, and it becomes x plus y will be equal to 0, minus x minus 3y plus z equal to 1, and minus x equal to minus 1. It means x is 1. So if x is 1, then y is minus 1, and let's solve it right here. Just rough it. So let's see, x is 1, y is minus 1, and for z, let's see, minus 1 minus 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 3 plus z will be equal to 1. So this becomes 2 plus z equal to 1, and z becomes minus 1. So x is 1, y is minus 1, z is minus 1. X is 1, y is minus 1, z is minus 1. Option C is correct. Next question. If force F, acceleration A, and time t are chosen as the fundamental quantity, find the dimension of energy. You have to find the dimension of energy. For which quantity? Force, acceleration, and time. Energy is force, acceleration, and time. So for acceleration, we have to write capital A. And let's see, let's assume x to the power. And for energy, ml square t minus 2, and ml t minus 2 for force. For acceleration, lt minus 2 power y, and for time, t power z. Let's sort out this. M to the power x, l to the power x plus y, t to the power minus 2x minus 2y plus z. Okay. Now let's compare. X will be 1. Okay. X plus y will be 2 from this and this. So 1 plus y equal to 2, and y is also 1. For z, minus 2x minus 2y plus z will be equal to minus 2. Minus 2 into 1, minus 2 into 1 plus z will be equal to minus 2. So minus 2 plus z will be minus 2. Minus 2 to minus 2 cancel, z will be 2. So x will be 1, y will be 1, z will be 1. It means f to the power 1, a to the power 1, t to the power 2. Okay, right here. F to the power 1, t to the power 2, option B is correct. Now move to the next part. If E and G respectively denote energy and gravitational constant, E upon G has the dimension of. So it is quite long question, but pretty simple. E upon G dimension. E is energy, ml square t minus 2, and G is gravitational constant. For gravitational constant, F is equal to G m1 m2 upon r square. G is fr square upon m1 m2. Let's sort out it here. ml square mlt minus 2 for force, l square for length square upon mass square m square. So let's see, m to the power minus 1, l to the power 3, t to the power minus 2. This is the value of gravitational constant. M minus 1, m minus 1, l minus l3, t minus 2. So just solve it. M to the power 2, l to the power minus 1, and t to the power minus 2 to cancel. M to the power 2, l to the power minus 1, and t to the power 0. This is correct, option A. Now move to the next question. In an experiment, the percentage error occurred in the measurement of physical quantity A, B, C, D are 1%, 2%, 3%, 4% respectively. Then find out the value of percentage error in x. So delta x upon x into 100 will be equal to twice into delta A upon E into 100 plus 1 by 2 delta B upon B into 100 plus 1 by 3 delta C upon C into 100 plus 3 delta D upon D into 100. Just put the value for A, B, C, D 1, 2, 3. So 2 into 1 plus 1 by 2 into 2 plus 1 by 3 into 3 plus 3 into 4. So 3 to 3, 1 to 1, 2 plus 1 plus 1 plus 12. That is 2, 3, 3, 4, 4, 12, 16, 16%. That is 16%. Option A is correct. Now next question. The percentage error in measurement, the G. So G is 4 pi square L upon T square. So delta G upon G into 100 will be equal to delta L upon L into 100 plus twice into delta T upon T into 100. Okay, now let's see. But in our question, the value of L and T are not given in percentage. It means we have to put the value of relative error. So delta L is this 0.1 upon actually L, that is 10 into 100 plus 2 into how much? 1 upon 100 into 100. So 100 to 100 cancel out, 10 to 10 cancel out, and it becomes 1 plus 2 into 1, that is 2%. So quite simple. Now, so our question is end right here, and we have covered unit and dimension, almost every question that appears in NEET, and we see the concept and everything related to those questions. Thank you.